In this video, I'm going to go through some stuff from section 2.5, which was finding values from probabilities. And so if you watch 2.4, this is kind of the opposite, where I'm looking at the percent, and I want to find the z-score or the data point that represents that percentage. So we're still using the z-tables. Remember that the formula for the z-score is data point minus the mean divided by standard deviation. I'm actually using an example situation from the previous section 2, so the heights of 8-year-old girls. They tell us that the mean of their heights in the school district is 50 inches and that their standard deviation is 2.5 inches. So I filled out the percentile normal distribution to show that as a reference point. So I put the mean in the middle, I added 2.5 to get the 3 values on the left, I subtracted it to get the 3 values on the right. And those represent z-scores of 0, 1, 2, 3, and -1, -2, -3. So in these questions, they're asking us to find two things, to find the z-score and the data value that's in certain percentiles. So if they're asking us to find this related to the 15th percentile, I put this percentile graph on there so we could kind of estimate. So if 16% is here, that would mean that the 15th percentile would be a little bit lower than that, right? So I know that if that's my 15th percentile, that my z-score should be a little bit smaller than -1, and that my value should be a little bit smaller than 47.5. Okay, so this is giving me kind of a checks and balance to make sure that my answer is reasonable. So remember that what I'm looking for is the closest value to 15% on the z-table, meaning the closest to 0.1500. Okay, so we know it's going to be a negative value, so we're going to look at the negative z-table. And if we zoom in, 15s, so I got 15s here in this row with -1.0. So looking at this, this is probably my two closest values. And so I want to pick the one that is actually the closest to 15. So 15.15% compared to 14.92%, that's 0.15% away versus 0.08% away. So that means that this percentage is closer to 15 than the other percentage. So what we're looking at then is, what is the z-score? So if I go back, the z-score is -1.0. And then the hundredths place, if I go up, is 0.4. Okay, so -1.04 is my hundredths value. So that is the z-score. That's one thing that I wanted to find. From the z-score, I want to actually find the data value. So this is something that they kind of showed you a little bit less work. So just in case you were foggy on the steps, to find the z-score, I'm going to plug into the z-score formula. Or sorry, to find the data point, I'm going to plug into the z-score formula. So I'm going to do -1.04 is my z-score, is equal to what I want to know, the data value, minus the mean we got from the problem. The mean is 50, divided by the standard deviation, which was given to us as 2.5. So in order to solve for x, what I need to do is multiply both sides by 2.5 to get rid of my denominator. When I do that, that gives me -2.6 is equal to x minus 50. So then to solve for x, I would add 50, which would give me an approximate data point of 47.4. 47.4 inches. Remember that we want to check for reasonableness. So if I look at what we estimated on our percentile table, right, we said that our z-score should be somewhere close to -1, which is true, and then it should be close to 47.5, smaller than that, and we got 47.4. So that is within our range. I'm gonna do one more example that's that same kind of procedure. It's just a higher percentile. And so we're going to have a positive z-score. So if now I'm looking for the 63rd percentile, then if I look at where this could land, so if this is 50 and this is 84, I know that the 63rd is going to be somewhere over here. So that looks like I should get a z-score that is between 0 and 1, and a height that is between 50 and 52.5 inches. Okay, so we're going to look for something as close to 63% on the z-table. Because I have a positive z-score, that means I'm going to look at the other z-table. So I'm looking for something as close to 0.6300 as I can get. So that's going to be up here. So I'm going to be somewhere in this range. And I want to figure out which one is closest to 63. And so that's going to be the smaller one. So that's not a highlighter. So 0.6293, 62.93% is 0.7 hundredths away, versus 63.31 is 31 hundredths away. So that's going to be the closest. If I look at my z-score, that means it's 0.33. So we're going to use 0.33 as our z-score. Z-score is 0.33. So when I'm solving for the data value, I'm going to do 0.33 is equal to, I want to know the data value. The mean is 50, and the standard deviation is 2.5. So my process is the same. I'm going to multiply by 2.5 and then add 50 because I'm using the same situation. So if I multiply both sides by 2.5, that's going to give me 0.825 is equal to x minus 50. And so then adding 50 to both sides, that gives me that my x value is 50.825 inches. Okay, so again, checking for reasonableness, we said that our z-score should be between 0 and 1 over here, which 0.33 is, and that our value should be between 50 and 52.5, which it is. Okay, so those are reasonable answers. The last one is different because I'm not talking about percentile. So I am talking about a percentage. So if I want to find the upper 35% of data, what I'm doing is looking at an area on the right side of the normal distribution. And so when I'm doing that, what I want to use is symmetry. So if I think about looking at the lower 35th percentile, so if I look at the lower 35%, so if I look at having pen problems, sorry. So I'm looking for the lower 35%. Because of symmetry, if I find that percentage, it's going to be the same as the upper. So what that means is I want to look for that thing closest to 0.3500 in my z-table. So that would be, let's see, 0.3500, the closest thing to that would be here. And so that's going to be the value 0.3483. So if I look at the z-score that gives me is negative 0.39. So that represents the lower 35%. So if that z-score is this negative 0.39, based on symmetry, that would mean that the upper 35% would have a z-score of the opposite sign, so of 0.39 positive. Okay, so the z-score for the upper 35% is 0.39. So then if I want to find the data value, so if my value is here between 0 and 1 again, my data value should be between 50 and 52.5. So I have to use that same formula. So my z-score is 0.39 is equal to the x value minus the mean of 50 divided by the z-score of 2.5. So if I multiply both sides by 2.5, I get 0.975 is equal to x minus 50. So that means that x would be 50.975 inches. Okay, so remember that symmetry is helpful. If it's asking you for something above a percentage, always just look for the below and then change the sign of the z-score. So since I got a negative z-score for the lower 35%, I just have to change that sign to get the upper.